Evaluate the square root of 8 minus 6i in the form a plus bi. Remember, 8 minus 6i is a number, it's a complex number. We're asking to find the square root of that number. Now, we know that for real numbers, that's not always possible. We can't always square root a real number and get another real number. For example, the square root of -2, we can't work out as a real number. We need complex numbers for this. But because the complex numbers are what we call closed, we can. The square root of a complex number will be a complex number. So that's what we're going to do here, and we're going to see how we can solve this kind of problem. Now, the way that we do this is we say, we know that this is of the form a plus bi. So the first thing we do is we say, let, I'm going to call this number z equal the square root of 8 minus 6i be equal to a plus bi. That is, this is some complex number, a plus bi. We just don't know what a and b are yet. And because this is a complex number, a and b are real numbers. But from there, we can start manipulating this, because that means that z squared is equal to 8 minus 6i, which is a plus bi all squared. So 8 minus 6i is equal to, expanding this, it's a squared plus 2abi plus b squared I squared. But I squared is equal to -1. So this is telling us that 8 minus 6i is equal to a squared minus b squared, collecting the real bits, plus 2abi. But that means that the real bit here, a squared minus b squared, must be equal to 8. And also that the imaginary bit here, 2ab, must be equal to -6. And now we end up with a pair of simultaneous equations that we need to solve. We start by rewriting this one as b equals -6 over 2a, or -3 over a. And substitute that in over here is going to give us, let's do that in the color so we can color code it, -3 over a, and all of that is being squared. And we can now solve this equation because this only has one unknown. This is a squared minus 9 over a squared is equal to 8. So that's a to the 4 minus 9 equals 8a squared, or a to the 4 minus 8a squared minus 9 equals 0. This is a quadratic in a squared, which we will see how to solve a little bit more in the next unit. But we did see an example of this in skill 21 as well, solving this kind of problem. So factorizing this, we get a squared and a squared. And to multiply to give these, we're going to end up with +1 and -9. That would expand to give that. Take a moment to double check that if you're not sure. But knowing that, we have that either a squared is equal to -1 or a squared is equal to 9. This one is not possible. And the reason this is not possible is that a is a real number. So that means a is equal to plus or minus 3. But now that we know a, we can substitute that back into here. And that's going to give us b is equal to -3 over plus or minus 3. Which means b is equal to -3 over 3, which would be -1. Or -3 over -3 would be +1. Let me write that like that. And the reason I've written this one as minus plus rather than plus minus is because when a is +3, b is -1. When A is negative 3, B is positive 1. So it's the other way around. Now that's quite important that these are different. We could have written this paired up as we could have written it as A equals 3, B equals negative 1, A equals negative 3, B equals positive 1. That would also be a perfectly valid way of writing that. But what's our actual values then? Because we were actually trying to find what the square root of 8 minus 6i is. So the square root of 8 minus 6i is equal to, well, we said it's equal to a plus bi, so it's equal to two things. It's either equal to 3 minus bi, so 3 minus 1i, so 3 minus I, or minus 3 plus I. Two possible answers for the square root of this complex number, 3 minus I or minus 3 plus I.